I am Kamal, and this is uh, the discussion on atomic theory. Here, this is our first episode on atomic theory analysis. Today we're going to discuss Dalton's atomic theory. This is the first episode, and if you enjoy it, then please like the video and subscribe. Hit the button to get more videos, informative videos. Like this. Thanks. So we discuss, we see a brief description on John Dalton. So, who is John Dalton and what is atomic theory? John Dalton was a English chemist and physicist and meteorologist also. So we can say that he deals with science. He deals in science. Actually, simply we can say that he is a scientist, English scientist. What discoveries and researches he has made? So, John Dalton worked on gas laws. He worked or researched about multiple gases like propylene, like methane, etc. When he working on these projects, he introduced or demonstrate the concept of atomic theory. It is known that he was the first to discover the process to calculate the atomic mass for the first time. So he was the one who discovered the process to calculate the atomic mass for the first time in the world, in history. Okay, so that is how important his works and his theories. He was the first to describe the atomic theory. No scientist ever discovered or introduced any concept about atom. He, John Dalton, was the first one to ever establish a theory or concept about atoms. So here we study about the atoms, the atomic theory, John Dalton's atomic theory. So according to John Dalton's atomic theory, atoms are the smallest building blocks of any matter we see, touch in our surrounding, in our earth. We can say everything what we can touch, we can feel, we can smell, whatever matter it is made of atoms. There are some postulates there are some postulates given by Dalton himself these postulates somehow clarify or describe, the better word will be describe, the characteristics of atoms. So next we discuss about the postulates of Dalton's atomic theory. Postulates of Dalton's atomic theory. Number 1, any matter is made of simple or compound particles. These particles are called atoms. Now according to Dalton, there are two types of particles. One is simple atoms and other is compound atoms. So for example, simple atom make simple matter. Now you ask me what is simple matter. So simple matter for example I can say a iron rod. Suppose a rod, maybe this is a rod, this is a iron rod, and this is made of iron. All iron molecules made this rod. Okay, iron atoms. So we can say this iron rod is a simple matter because it's made of only iron. Is only made of iron. There is nothing else, only iron. But the another type is compound atom. Compound atom. Now what is compound atom? Compound atom, for example, sand. Let's draw some sand granules. These are sands. So sands is an SiO2, silicon dioxide, is a chemical formula. There is a huge amount of sand in our earth crust. So the abundance of silicon dioxide, which also help us to make semiconductors in future. Maybe if we try to bring more solar energy into effect, then we need more silicon dioxide, and which we have in our earth crust. So this sand is made of two elements. One is silicon, we call Si, and other is oxygen, we call oxygen. So these are the two elements which the sand is actually made of. So this is why it is called compound atom. Means in simple compound matter, sorry, I made a mistake here. This will be compound matter. Okay, so what is the difference between simple matter and compound matter? Let's imagine a iron rod which is made of only iron, is only one element in the whole rod, which is iron, Fe. We call it ferrous. This is iron rod, and here is sand, which is made of two elements. One is silicon, another is oxygen. So this is compound because it takes two elements to form. This is the first postulate of atomic theory, Dalton's atomic theory. First postulate. We have many other postulates as well. So now we talk about the second postulate. According to Dalton, these atoms cannot be broken by any physical or chemical reaction. So according to Dalton, these atoms which made the matter cannot be broken by any physical or chemical reaction, or these atoms are unbreakable or unbreakable. Okay, what is called unbreakable or unbroken? Let me see. whatever, unbreakable, it cannot be broken. Okay, but can you say, I want to ask a question, is it really that we cannot break this atom? Really? Please, if you interested to answer this question, please write the answer in comment box. I will be very happy to see your answers. So this is the second postulate of John Dalton, and now we're going to be going to the third postulate. It says each atom of same elements will be similar in every aspects, like mass, size, diameter, and other physical or chemical other characteristics, we can say. So for example, you can say, if we take an iron rod again, we are going back to the iron rod again. So when we see an iron rod, all iron atoms are same, like their weight, their size, I mean atomic size, atomic size, and every other characteristics, like its valence, number of valence electrons, number of protons, everything is same. There may be other isomers or something else, but that is another part. But actually every atoms from similar same element, every atom of same element, like ferrous, here we take ferrous, or we can say aluminium. Every aluminium atom will be same in size, in weight. If one aluminium has 27 atomic mass, then every aluminium, actually no I'm making a mistake. No, I correctly, I have written correctly. If aluminium has 27 atomic mass, then every aluminium atom will have 27 mass. So every character of the same, every character of every atom of same element will be same. Means here aluminium, if we take aluminium, the diameter of every aluminium atom will be same. So this is the third postulate of John Dalton. Now we are going to the fourth postulate of John Dalton. This is the just opposite to the third postulate. Every atom of different elements have different characters, weight, size, atomic diameter, valence electrons, and many other characteristics. So as the every atom of the same element have same characteristics, weight, size and others, similarly every atom of different elements, like one, here we take one iron and one aluminium, or so suppose we take here one sodium and one aluminium. So this sodium has an atomic mass of 23, where every aluminium atom has an atomic mass of 27. This is the thing. Okay, this is the fourth postulate of. It means that every atom of same element will have same characteristics, same weight, same size, same diameter, and similarly every atoms of different elements, means if we take that sodium chloride is salt, the sodium of sodium chloride has the mass of 23. So every sodium atom will have a mass of 23. If we take sodium carbonate, then here is sodium, it will also have an atomic mass of 23. Every sodium atom, in every case we have 23 mass. And again, if we take aluminum hydroxide or aluminum chloride, every aluminum atom will have the mass of 27. This is the fourth postulate of John Dalton. Now is the fifth postulate of John Dalton. When two or more atoms take part in chemical reaction, in correct proportions, here is better way to say two or more elements, more than two elements take part in a chemical reaction in correct proportion, like 1:2:3:4, is a like, for example, one carbon atom reacts with two oxygen atom to make carbon dioxide. So here if we see that there is only one carbon atom which reacts with two oxygen atoms. One carbon atom reacts with two oxygen atoms to create a harmful gas for human and helpful gas for trees, which is carbon dioxide. Okay, so this is the fifth postulate. It means that every atoms of multiple elements react in particular proportions to take part in a chemical reaction. Like here, one carbon atom reacts with two oxygen atoms to form carbon dioxide gas. This is the fifth postulate. And the last and the final postulates is the most important and something which is most fundamental, that is the sixth postulate, that atoms can never be created or destroyed. This is the sixth postulate. There is one question of mine. If you want to answer that, if this postulate is right or wrong, is it right or is it wrong from John Dalton? And if right, then why is right? And if wrong is, then what is wrong about it? You have to answer it. Okay, if you say that this is the right, then why it is right? You are saying why. And if you say this is wrong, then why it is wrong? Just try to answer it, and we will be continuing this theory. This is the end of the episode.